Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. So today is day 13 of our series Brahmastra, where we're talking about most expected questions. We're dealing with most expected questions for your PU both syllabus. Today is math session number 3. As you all requested for continuity and differentiability chapter and integration, that will come later, but today's session will talk about continuity and differentiability. Okay, so this is just session number 1, part 1. I'll do this chapter in 2 parts. So tomorrow you'll get a session number 2, which will be continuity and differentiability part 2, where we'll talk about PYQs, questions on different categories, MCQs, basically according to the blueprint. Whatever they're asking in the blueprint for this current year, we'll do questions according to them. Okay, but today's session is a very important session. I know that you'll all love it. Today I'm going to talk about 25, more than 25 most expected questions from NCERT. So I'll teach you, as I do every session, I'll teach you some concepts. So I'll teach you concepts of continuity, differentiability, differentiation rules. I'll give you all of that in one place so that you don't have to go to other sessions and watch that session and spend time over there. If you're watching this session, everything will be completed in this session only. So I will do what? I will give you some concepts in the beginning, then I'll teach you 25 most expected questions from NCERT. So today's session is from NCERT only, which is going to help you in PU basics preparation for this particular chapter. I've taken entire chapter. We're going to solve 25 questions. You'll see how the questions will be. Okay, and tomorrow in the next session for PU Brahmastra, day 14, we'll talk about your mathematics session. In that we'll talk about what? Continuity and differentiability part 2, where we'll talk about PYQs. I hope this is clear. Okay, so I hope you're prepared. This is what we asked for, so I hope you're excited for this. Please take your pen and paper out. If you have the formula sheet, as I've been asking you for so long, take that pen, sheet with you. If you don't have it, it's okay. I'm going to give you all the formulas in the session, so no problem whatsoever. But if you have, you can just keep it just to refer it at times if you're not feeling confident in the formulas. Okay, so let me start with the first thing coming up for you in the PU Brahmastra for day 13. Mathematics is going to be your weightage, bacha. What is the weightage of this chapter going to look like according to the latest blueprint? So have a look. Okay, please have a look. So you have the category which is coming up like this. First category is MCQ, 1 marker. Again, you can expect 2 questions from here, 2 questions from here. All right, 2 questions from here, each of 1 mark, so 2 marks from MCQ section. Fill in the blanks. You can expect what, bacha? 1 question. You can get what? 1 mark in this category again. And short answer 2 marker, you can get what? 1 question you can be expected of what? 2 marker, because this is short answer 2 marker. Same thing with short answer 3 marker. Question number is only 1, and 3 marks you can expect in this because of 3 marker. And long answer 4 mark and 5 mark you can expect again 1 questions, which will make the tally for the total number of questions to be 7. 2 plus 1 3 plus again 4 is 7 over here. 4 mark and 5 mark total makes the tally to be 17 marks from this chapter, which is a very high weighted chapter for your boards. Okay, so please do not take it lightly. Any doubt, any discussion you want to have with me, let me know in the comment section. Sir, I want this thing particularly, sir, this can be improved, but there, sir, whatever your questions, queries are for this chapter should be answered. So please let me know in the comment section. Okay, very important chapter according to the weightage and the latest blueprint of your boards. Okay, chaliye. Now if you look at this, excuse me, content index, how I have planned the session. So if you see the bacha, I want to solve first 8 questions on only continuity. Only continuity I'll solve, total of 8 questions. Okay, next I'm going to solve next 10 questions on differentiation and differentiability. Okay, we'll talk with respect to both the type of questions. We'll check for differentiability, we'll understand from the graph point of view also. And question number 19 to 21, parametric form. Okay, total 3 questions there. And second order derivative I've taken 3 questions again, and 25 27 miscellaneous questions also have taken 3 more. Okay, so these 9 are very good questions. You'll see that even the other 18 are very good questions. I've taken what? 27, right? 27 most expected questions from your NCERT. Means if you solve these 27 questions, if you're comfortable enough to solve all the questions without any help, these 27, then you are prepared from NCERT portions. Your NCERT is complete. So those type of questions I've taken. If you can solve all these 27 questions without any help, without my help, then you are prepared, you are ready. Okay, so I wish that you're gonna be that ready after completing this session. Okay, let's start. But in order to do so, what you have to do, you have to solve all these questions. And how can you solve it? Please join the WhatsApp channel, get the class note, the PDF form of the class note, and solve all these questions, okay, again and again, to get confident in this question by practicing on it. Okay, chaliye. Coming up first is what? Continuity. So when can we call a given function fx to be continuous? Please check. When can we call a function fx to be continuous? Okay, so again, if you're talking about continuity or differentiability, we talk about at a point. Okay, so let's say at a point x equals to c, we're talking about a point x equals to c. Then what we're gonna look for, bacha? We're gonna look for, first thing is left hand limit. We look for left hand limit, and how we define it, if you remember, limit of the function fx when x tends to what, bacha? C from the left side. Okay, and same we do what? Right hand limit. Okay, this also is written as what, bacha? L1, and if you write this as L2, right? For the short form L2. So RHL will be what? Limit f of x when x tends to c plus. Please find it out once you, and how you do that, if you remember, in place of x you're going to replace what? You're going to replace this as c minus h, limit function of c minus h where h tends to 0. Okay, for this you're going to write what? Limit, I don't have to teach you this, you have already learned in PU1, but just revising it, how to find the left hand limit and right hand limit. Limit h tends to 0 again for right hand limit. Okay, once you get these values L1 and L2, okay, find one more thing, f of c. What does f of c represents? Function's value, the given function's value at the point c, and if I'm getting L1 equals to L2 equals to f of c, not two combination, not the first two combination or the second two combination, it has to be all the way. L1 equals to L2 equals to f of c, means left hand limit should be equal to the right hand limit and should be equal to the function's value at that point. Then only we can call the function fx is continuous at point x equals to c. So what's the definition of continuity? For a function to be continuous at any given point, the left hand limit should exist, the right hand limit should exist, and should be equal to the function value at that point. I don't have to teach you how to find the limits, but just for recollection of the thing that you have learnt, I have given the standard form of the limits to find left hand limit and right hand limit. Simple. Shall we move on, please? Okay, chaliye. First question on this category only. Okay, so I can solve this question two way, algebraically, okay, or graphically. So using algebraic method, how can I solve it, bacha? Please check. So if I'm finding the left hand limit, which part of the definition of the function I'll use? The function is defined in two parts. Okay, part one, when, okay, this is x is missing here, bacha. If x is less than 0, if x is less than 0, this is nothing but, please check, x is less than 0, my bad. Okay, when x is less than 0 means the function is defined as x square. It's a polynomial, second order quadratic function. Greater than 0 was the function linear x. Okay, linear x. So if you see the graphical approach, after greater than or after 0, this is the function y equals to x, and before 0, this is the function y equals to x square. Is it continuous or not? It is continuous. No, please check. Is there a break in the function? There is no break, sir. So it is a continuous function. Okay. Now, how about algebraically? How will you solve this same thing using algebraic approach? So if you find the left hand limit, please check left hand limit, bacha. You'll use which one, or this one, or this one? We'll use this one because less than 0 means we have to approach 0 from the left side. So this is going to be my left hand limit. Find the left hand limit is going to be what? Put 0 over here. 0 square, how much is that, bacha? 0. Okay. What about right hand limit, sir? What about right hand limit, sir? We have to use this function for the right hand limit. Approach 0 from the right side, so we have to use the linear function. It will be what? 0 simply, because x is 0, right? So please check, x is 0. So for that reason, I'm getting what? I'm getting left hand limit is equals to right hand limit equals to what? Function value at 0. For that case, what happens? This function given over here defined like this, when x less than 0 is x square, greater than 0 is x, is continuous at point x equals to 0. Both approaches shown to you using graphical approach or using algebraic approach to you. Okay, chali. Please have a look. Moving on to the next. One more thing I wanted to show you. How would you discuss the point of discontinuity for greatest integer function? Again, we'll see both graphical approach and algebraic approach. Look at the graphical approach. Let's look at the graphical approach first, sir. How does the graph look like, if you remember? Okay, here a dot is there, open, dot is there, open, dot is there, open, open, dot is there, open, dot is there, and like that. What are the points, bacha? This is 0, this is -1, this is also -1, -2, this is -2, this is 1, 1, 2, 2, and 3. Okay, you understand the graph? So means at every integral point, please check, at -2, -1, 0, 1, 2, there's a jump in the function, no? There's a step in the function. It means function defined like this, y equals to greatest integer function of x is what, bacha? Is discontinuous at x belonging to integers, whether it is positive or negative. For all x to be integers, the function is discontinuous. Please have a look once again. No problem, sir. Please check. -2, -1, 0, 1, 2, 3, 4, like that. What about 1.5, sir? 1.5 is over here, no, sir? Is the function before and after the same thing value? It's continuous. No, please check. There's no break. At x equals to 1.5, sir. Before or after, is the function is having any break? No, sir, it's a straight line, no break in the function. It means it is going to be a continuous function. Okay, this is a graphical approach. Have a look at algebraic approach. So if I'm defining like this, y equals to x, okay, greatest integer of x. So if I'm looking for what? To find left hand limit, check here. If I write here limit of x when x tends to what? Let's say any integer c from which side? From the left hand side. Okay, what will this become, bacha? Tell me. This will become simply c minus 1. How come so? Check. If I go at point, let's say 1, I'm approaching 1. Okay, 1 second. If I'm approaching this point, let's say, bacha, 1. Okay, before 1, what's the value? Tell me here. Before 1, the value is 0, bacha. Have a look. Value of y before 1 is what? This value, sir. Value of y before 1 is what, sir? This value which I've marked. If it's not visible, I'll write it again. Please check. This is the function's value before, right before 1. Because this is equals to what? This is equals to x equals to 1, right? At x equals to 1, right before x equals to 1. Take here, please check. 0.99999 like that. What's the answer, bacha? Answer is going to be 0, no, sir? Answer is going to be 0, sir. That's what I'm saying. Right before 1, answer is 0. And right after 1, please check. 1.00000 like this, 1. What is the answer for this? 1, sir. So if for the left hand limit, you're going to get what? C minus 1. And for right hand limit, you're going to get what? This is my L1 value. What about L2 value, sir? Limit. What is it going to be? For function x, when x tends to what? C from the positive side. What is this, sir? What is this, sir? This is going to be simply C. Simply C. Hence, is it equal? Can you see that? Is L1 equals to L2? No, sir. It means limit does not exist, right? So what happens to the function? Not continuous. Not continuous. Where? When x belongs to integer z. How come, sir? Because I've taken this number c to be a integer z. Okay, all right, this is clear. Please have a look. Okay, moving on to algebraic approach or algebra of continuous function. Let's see what happens to the continuous function if you put under algebra. So if you take two functions, if you remember, this is also from NCERT. If you take a function f continuous at a point C, sir, okay, and I take another function g continuous at a point C again. F and g both are continuous at function at the point C. Okay, this is defined like that. Okay, this f can be a trigonometric function, g can be a polynomial function, but whatever it is, whatever is f and g, idea is that they are both continuous at point C. Chalo, theek. Now the properties are that sum of and the difference of the function means f plus g or f minus g is also continuous at the point C. I've taken question on this, don't worry about it. Second one, f into g, if you do, is also continuous at point C. If you take what, bacha, last one, f divided by g is also continuous at point G, provided what? The denominator is not 0. 1 second. Yeah. So this function g cannot be equal to 0, sir. Okay, the function cannot be equal to 0 at point C. Chali. This is it, right? So 1, 2, 3 is also defined. This is called as the algebraic approach, or whenever we are using algebra of continuous function like this for the two function which is already defined as continuous at the point C. Okay, simple thing, very simple thing. Questions can be asked. That's why I wanted to teach you this. Now coming to differentiability, what is it going to be? We have to write the derivative from the first principle. So f dash of x, what is this? Derivative of the function fx is given as what? F of x plus h minus f of x upon x plus h, sorry, the limit under, right? Limit h tends to 0, x plus h minus x, right? So I can cancel this x and x, I get what? H. So if you define it like this and write the value for left hand derivative and right hand derivative, right? Left hand derivative we're going to do what? Write it as x minus h, and right hand derivative will be the same thing, x plus h. If you do that and get what? You get left hand derivative equals to right hand derivative, then we can say what? The function fx is differentiable at that point. Okay, what is it? This is the first order derivative. From there you can find left hand derivative using x minus h over here. Okay, you're gonna get minus h in this case, and right hand derivative is same thing. When you use that, get the value of LHD and RHD. If they are coming equal to each other, then you can say what? The fx is derivable, or differentiable or derivable at the point wherever you are finding it out, C or A, whatever it is. Okay, chaliye. Very simple definitions. I wanted to explain you that as well. Now few properties of differentiation, sir. So let's say you are asked to, what first one? You are asked to differentiate two functions given like this. Differentiate about two functions given like this. What you can do? So differentiate the first one, keep the same operation, and differentiate the second one. If it is u plus minus v differentiation, you can write the differentiation of u plus minus differentiation of v. So you can operate and differentiation like this. So first for u, then plus minus for v. Okay. Next one, also called as product rule, sir. Also called as product rule. If you have to, you are supposed to what you call differentiate product function given in product. Okay. What are you gonna do, bacha? Keep u as it is, differentiate v, plus keep v as it is and differentiate u. Differentiate u. Okay, we can do in any order because it's a plus sign, no? So I can keep this here also, this there also, not a problem. Okay, great. Third one is what, bacha? Quotient rule. Quotient rule. What is this? If the function is given in ratios like this and you ask to find what? The differentiation, answer will be what? The numerator you're going to differentiate keeping the denominator same, so keep v as it is and differentiate the numerator, so u derivative minus sign will come, keep this time u as it is and differentiate what? The v. Okay, divide by the square of the denominator, so v square. Okay, the last but not the least, chain rule. Okay, so without knowing it, you are applying chain rule all the time actually. Okay, so for example, if I ask you to differentiate what? I have function y equals to sin x. What's the answer, sir? Sir, cos x, sir. Sir, I did not use chain rule over here. I'll show you. What if I wrote it like this, sine of x square? Sir, answer for this is cos of x square, sir, times of 2x, sir. Because first I'll do sine, sir. Sine is a trigonometric function. Answer is cos, sir. But the theta will be x square, so x square, sir. And for x square will do for 2x, sir. For x square will be 2x. So, sir, answer is 2x times of cos x square. Great. What is this? 1, no? So, without knowing it, sin x, you have taken the chain rule as 1. Because for sin x, it is cos x. X is also a polynomial function. And what's the differentiation of x? Always 1. That's why you've taken 1 already. But since it is 1, you're not, showing it. That's why. But without knowing, you're always using this chain rule. What is it? If you're, let's say, writing this differentiation of dy by dx, okay? This is the way to show differentiation. Other ways to be what, bacha? y1 or y dash. These are the ways to show the differentiation for the first derivative. Chaliye. How will I write it? I can differentiate this dy with another variable dt. and what? Differentiate dt with dx. Means you can see that I have gone in chain to what do you call differentiate the given function, y with respect to what? T first, and then t with respect to x. Okay, check, I differentiated first cos x, then I did what? I differentiated first cos x square, then I did what for x square, which is 2x. We'll see in the question, don't worry about it. These are the rules. Okay, if I want to do with more variable, I can do with more variable also. dt by ds I can do, then again I can do what? ds by dx. This chain can keep continuing till any end, whichever you have a requirement for. Please have a look. Now I will give you the most important that you think you're waiting for. You keep asking in the sessions also, sir, formula sheet. Why don't you make formula sheet by yourself? How difficult is that? Okay, please make the formula sheet by yourself, but I will give you, since I'm going to use these formulas in the session today, that's why I'm giving you the formulas anyway. So please have a look. Okay, your demand fulfilled by us. Okay, first function that you know of for the polynomial function. Okay, or before that, let's say I have a constant c is a constant, sir. So differentiation of a constant with respect to what? A variable c is always 0. So if you're differentiating 2 root 2 anything, which is a constant, fraction, irrational, doesn't matter, if it is a real number constant, differentiating it, getting the answer is always 0. Constant differentiation is what? Always 0. Second differentiation, polynomial, please check. Differentiating, sir, a times of x power n. A times of x power n. A is the constant, I can take it outside and write it as a times of differentiation of x power n by dx, and this will give me the answer to be a n x power n minus 1. I hope you got it. Okay. Third one, differentiation of e power x, exponential function. This was polynomial function, this is exponential function. What is it, bacha? Tell me here. So this can be what? This can be same thing, e power x. The next one, what if I have differentiation of logarithmic function? So ln x. Answer is what, bacha? Answer is simply, sir, 1 by x. Now another important case, what if I have differentiation of function given like this, a power x, answer is a power x ln a power x times ln a. Okay, chali. Now fifth formula is done. Sixth one, let's do sum of what? Trigonometric function, differentiation of sin x. What is this? Always, sir, cos x. Next one, differentiation of cos x, sir. Answer is what, sir? Sin x? No, sir. Minus sin x, sir. Okay, minus sin x, sir. Chaliye. Eighth one, differentiation of what, bacha? Tan x. What is this? Sec square x. Sec square x. Ninth one, differentiation of sec x. What is it? Sec x into tan x. Okay, sec x into tan x. Okay, so I've done 1 2 3 4, right? Which I've missed. Okay, I missed for cot, right? So for cot I'm going to do what? Differentiation of cot x will be what, bacha? Same thing with the minus sign. So minus cosec square x. Okay, I hope this is all visible to you. Yes, I've tried to keep it neat. Yes. Formula number 11. Hey, देखिए, 11th one is what? Differentiation of cosec x. How much is that, bacha? This is going to be minus cosec x into cot x. Please check. There's a pattern, sir. There's a pattern, sir, here. Tan is sec square, so cot is minus cosec square. Okay, sec is sec x tan x, so cosec is minus cosec x tan x. Okay, have written for all of them 1 2 3 4 5, and the sixth one is there. Okay, we also have some very important formulas differentiation of sine inverse of x. What is it, bacha? 1 upon 1 minus x square. Okay, 1 upon 1 minus x square. 13th one, differentiation of cos inverse of x minus 1 upon 1 minus x square. Okay, the last one, which is used most often in the inverse trigonometric function category, tan inverse of x. So 1 upon 1 plus x square. Okay, 1 plus x square. Can you see that? Yes. Okay, great. Chaliye. Now moving on to, these are the formulas that is there. Please have a look. Please have a look. Okay. Okay, so find the relationship between a and b so that the function f defined by this is continuous at x equal to 3. Continuous means what? It means, sir, L1 equals to L2 equals to f of 3, sir. Okay, what is f of 3? Please find f of 3 first. F of 3 is going to be found using this one condition. Equality is over here. So I'll have 3a plus 3. Sorry, 3a plus 1, right? F of 3 is what, bacha? 3a plus 1. Have a look. I'll put it in this condition. So a times of 3 plus 1. What is that? 3a plus 1. Great. Now what about the left hand? Do I have to find both of them? I can find the right hand limit directly from here. Please check. For b, what is my L2 going to be, bacha? L2 going to be bx plus 3, right? Put x value now. So it's going to be b times of 3 plus 3. Why am I not finding the limit value in this case? The limit value is this, bacha, actually. Okay, why is that substitution? Because there is no indeterminate form. Okay, so 3b plus 3. Now from this condition of a continuous function, I know that L2 has to be equal to what? F of 3. Please check. So 3b plus 3 equals to 3a plus 1. Okay, so if you check this, I get what? 3a equals to 3b plus 2. If you bring this 1 over here, it's going to be minus, so 3b plus 2. Okay, so what is this? This is a relation, right? You can write this as this, or write this as 3a minus 3b equals to 2, which is nothing but a minus b equals to 2 by 3. Whichever is the way that you want to write the answer to be final answer, this is the last answer that you can write it as 3b plus 3, a minus b equals to 2 by 3. A minus b equals to 2 by 3 sum. Okay, chaliye. Okay, you can write both of them as answer. Actually, not only this, you can write both of them answer. You can write both of them as answer. Even this is true. Both the conditions are valid, bacha. Okay, great. Chaliye. So question number 3, for what value of lambda is the function defined by this is continuous at x equal to 0? चलिए देख लेते हैं. So 0 means, let's find at 0 L1 equals to L2 equals to f of 0. What's f of 0, bacha? From here we'll use f of 0 will be what coming as? Put here lambda times of 0 minus 0. So simply what? 0. What is going to be L2? L2 will be what? Please check. L2 will be 4 times of 0 plus 1. I'm getting what? 1. Array, this is what is coming. L2 not equal to f of 0. So forget about the lambda value. It is not continuous only. We can write what? Discontinuous at x equals to 0. What is discontinuous? Fx is discontinuous at x equal to 0. Okay, we cannot find the lambda value from here. Chaliye. What about the second part? What about continuity at x equals to 1? X equals to 1 means after 0, right? After 0. So x equals to 1 will come when? When x is greater than 0. What's the function going to be? The function is going to be 4x plus 1. This is a straight line, right? Means what? Always continuous. It means what? Continuous. So the function fx is continuous at x equals to 1. So for 0 is discontinuous, for 1 it is continuous. Please have a look. For 1 it is continuous because it is going to be a straight line. No, 4x plus 1 is a straight line. Okay, chaliye. Have a look. Now this is visible. Moving on. Question number 4. So that the function defined by gx equals to x minus greater integer of x is discontinuous at all integral points. All integral point. चलिए निकालते हैं. What is this? This is going to be GIF only, greater integer function. Okay. All right, so let's find बच्चा L1. So limit what I can write? H tends to 0. Okay, h tends to 0, and it's going to be what, bacha? I'll replace x by, so simply c minus h minus yes or no? Think about it. What is c minus h? So if I'm writing one more step, it will be clearer to you. It will be clearer to you, sir. So basically I'm doing what? I'm doing limit x tends to c from the left side, so c minus, what is it? X minus greater integer of x. Okay, when I do that I have to write what? C minus h. I can write s equals to 0. That's how we find the limit, no? Replace x by c minus h and then write what? H tends to 0. This is the definition of the left hand limit, है ना? Definition of the left hand limit, please check. This is going to be what? This is not an indeterminate form. This is not an indeterminate form. So it will become what? Simply c minus 0. What about this, bacha? Before c, so value of function, please remember this. If I'm writing x, okay, or just simply what? This c, okay, defining like this. So when I'm writing for x less than c, okay, less than c, what is the value, sir? It's going to be c minus 1, yes or no? If I'm writing x greater than c, what's the value, sir? Simply c, right? After, not 1, c. After c, the value is going to be what? C, okay? On the right proximity of the c value, this greater integer function will become c only, and right before c, the greater integer function will become c minus 1. That's the definition I explained to you in the graph also. Please check. So c minus h will become what? This will become, so simply, please check. This will become, one second, c minus 1, sir. Okay, expand the bracket. C minus c plus 1 goes out. This is 1. What is this going to be? My left hand limit. L1 is 1. Now how about L2? Please check L2. So I'll write L2 as limit of the function. What is the function? X minus greater integer of x when x tends to the value c, let's say, from the right side. What is c, bacha? What is this c? Please remember this. What is this c I'm taking here all the time? C is a value that belongs to integral set, because we're looking for integral points, no? So c is an integer, okay? So c plus if I do, then what happens? Please check. This can I can write again as limit h tends to 0, okay? Instead of this I'll write x what? C plus h. C plus h, okay? In this also I write what? C plus h. Great. Check this value. This is not an indeterminate form, so I can substitute this h as 0. So c plus 0, c plus h, greater integer function. C plus h means if you add something next to this, c plus h is this only, no? More than c. What's the answer, sir? C only, right? So minus c. Check here. C plus 0 minus c goes out. What is the answer? Simply 0, sir. Simply 0. So my L2 is coming as 0, whereas L1 was coming as 1, right? L1 was 1, which means that L1 is not equal to L2. If my left hand limit is not equal to left right hand limit, means what? The function gx equals to x minus greater integer of x is discontinuous at point C, discontinuous at point C. And what does C represents? Integral value. So we can write what? Simply gx is discontinuous at integral point, sir. At integral point, sir. है ना? This is your answer. This is the final answer, sir. Please check. Please check. Okay. Great. Yeah. Have a look. Simple enough. Question number 5. Discuss the continuity of following function. What is this? Algebra of continuity. Sin x plus cos x. Sin x is continuous or not in the domain? Yes, it is, sir. Sin x is like this, sir. Always continuous like this. What about cos x, sir? Again like this only, no, sir? Yes. We know that if f is continuous, if f and g are continuous in the domain, right? What's the domain? For all real numbers, no? For all real numbers, continuous for x belonging to all the real numbers, it means what? F plus g will be again continuous, right? Same way, f into g will also be continuous. F into g will be continuous. Correct, right? What is f? F is sin x, g is cos x. Have a look. Simple enough. Okay. I'm not doing steps over here. Not required. You can check from NCERT also. But this is not, that a difficult question. Just want to take a question on algebra of continuity because I don't want to miss you or miss out on any concept which is there and not solving questions on them. Okay. चलिए आगे बढ़ते हैं. Find the value of a and b such that the function defined by this is continuous. Okay. A and b means I have to get two equations to find the values for a and b. I need two equations because there are two variables involved. Please check. I can check continuity at 2 points here, bacha, at point 2 and at point 10. Right? So check for 2. At x equals to 2. Check the continuity. Find left hand limit. For left hand limit, you're going to use this part. Right? So what is the left hand limit, bacha? Is going to be 5. Simply 5. What's right hand limit going to be? L2 is going to be what, bacha? Ax plus b. So a times of 2 plus b, right? How much is that? Simply 2a plus b. And they should be equal to each other, right? So what I'm getting? 2a plus b equals to 5. How come? We're looking for continuous function. Equation number 1. Next case. At x equals to 10. Okay, please check the left hand limit value. Okay, yes, L1 will be what, bacha? I'm going to use over here for L1. I'll get what? 10a plus b, right? 10a plus b. What about L2 value? What about L2 value, sir? Simply 21. It's a constant, no? So I can get what? L1 has to be equal to L2. Reason being, we are looking for continuous function. So I get what? 10a plus b equals to 21, equation number 2. Subtract 2 minus 1. So 1 from 2. If you do that, 10a plus b minus 2a plus b. So 8a plus 0, b minus b is 0. 21 minus 5, so 16. So what is, what is a going to be? A is going to be 2. A is going to be 2. What is b going to be, bacha? 1, right? Please check. Yes, no? If a is 2, 2 times 2 is 4 plus 1 is 5. So a is 2 and b is 1. A is 2 and b is 1. These are my answers. Have a look. Moving on to question number 7. So that the function defined by cos x square is a continuous function. Of course it is continuous, sir. How come, sir? Domain of x square. I have these two functions. Let's say I take this as f, function f. What is this going to be? Let's say g. So what's the domain of g, bacha? And before the domain of f, bacha? All real, sir. All real. Yes. Is it continuous? X square? Yes, sir. It is a continuous function. Looks like this, sir. So continuous function. Great. Okay. What about cos? Cos is also continuous function, sir. Looks like this, sir. So continuous function. Great. So what is the domain of cos? All real, sir. But even positive will work. Cos has a domain of all real, but even positive. What is x square value? Always positive, right? So if all real is okay, means positive is also okay. Correct? So domain is very, what is going to be domain for this part? For GOF. Domain of for GOF will be what, bacha? Only positive real numbers. For which is function g or cos defined, is it continuous? Yes sir, cos is continuous everywhere, so is also continuous what? On the positive side, is continuous where? Continuous at positive real numbers. Hence what? F is continuous, G is continuous, so GOF is also continuous na sir, for the given domain, right? Domain of GOF is what? Domain of GOF is R plus, right? Correct na? X square can be only positive, so domain of GOF is R plus. Domain of F is what? All real. Chaliye, simple. Have a look. So answer is yes. Answer is yes, it's a continuous function. Moving on to the last question of this section, which is going to be the continuity part. The last question we are doing. Find all the points of discontinuity of f defined by mod of x minus mod of x plus 1. Excellent question. So if we are looking to find what? Points of discontinuity, we have to figure out what? We have to figure out critical points, right? Figure out critical points, sir. If I do that, I have to put this to be 0 and this to be 0. Put it here. I get x as 0, and from here I get what? X as minus 1. Take here, x as 0 and x as minus 1. Okay, so plot the numbers, minus 1 here and 0 here. Okay, now if I'm looking for a function defined before minus 1, please check, before minus 1, which function is this, sir? Function fx only, before minus 1. Before minus 1, have a look bacha, before minus 1, on this side basically, what happened to the function fx? Mod x will be negative, right now? Check here, before minus 1, take a value minus 2. Take a value minus 2. If I put here minus 2, how will mod open? Mod will open with a minus sign to make this positive, right? So I can take that as minus of x. Means before minus 1, this inside part is negative. I have to make it positive, I have to get what? It has to be positive because the mod will operate, right? So mod operation is what? I have to open it with minus sign. So minus of x. Before minus 1, this also will be negative. So I'll open it with what? Minus sign again. Please check. So the mod is opening with a minus sign before minus 1 sign. So minus x, minus will become plus of x plus 1. Goes out, what is the answer, bacha? 1. So before minus 1, sorry, the function is what? Simply 1. Okay, simply 1. What is the next condition? X lying between minus 1 and 0. Lying between minus 1 and 0. Have a look. If I put minus 1 and 0, what will happen to this? This will be negative only, na bacha? If I put minus 0.5, put here minus 0.5, what will happen? Tell me. This will be what? Negative only, sir. So for this case now, when I'm taking for x between 0 and minus 1, the function fx will what? Bacha? It will be again minus x, but this time this will simply open with a plus sign, right? Plus x plus 1. Please check what I'm getting, sir. Minus x minus 1. How much is that, sir? Minus 2x minus 1. So write here the function to be minus 2x and minus 1. Getting it? Between minus 1 and 0, this part will be negative, this part will be positive, sir. So this minus sign will make this negative and this will make it again negative. So minus x minus 1. Minus x is minus 2x and minus 1. Okay, the last part. Write the function again. Fx is given by what, bacha? Fx is given by mod of x minus mod of x plus 1. The last condition is what? When x is more than what? 0, right? More than 0, yes. Okay, greater than 0. What will happen to this? This will be what? Positive. So simply x. And what is this? Simply, sir, positive only, na? Positive, sir. So x plus 1. So x minus 1 goes out, simply minus 1. What's the function, bacha? Here minus 1 when x is greater than equal to 0. Now I have defined my function. It's an excellent question, okay? What I've given over here, you know, is a very good question. As I said, these are most important questions from your NCERT. These are most important questions from your NCERT. So very, very important question. Now have a look. How many points of discontinuity that I can have? Only 2 points, sir. At minus 1 and 0. Now check at minus 1. So I'll add the function again over here. What's the function? The function that I've got here is defined like this. 1 minus 2x minus 1 minus 1 when x is less than minus 1, when x is from minus 1 to 0, when x is greater than equal to 0. Chaliye, this is how the function is defined. Please check. Okay, great. Now look at the point, what? Point x equals to minus 1. What is the L1? Tell me here. What's the L1, bacha? L1 is simply 1, right? What's the f of minus 1, bacha? Simply again 1, right? F of minus equality, please check. Check the equality. Again minus 1, sorry, plus 1. Equality is over here, so plus 1, no problem. What about L2, sir? For L2, put here L2 minus 1. It will become what? Tell me here. Minus 2 times of minus 1 minus 1. What is the bacha? Answer is plus 2 minus 1. What is the answer? Is again 1. So what I'm getting at point x equals to minus 1, I'm getting this as L1 equals to L2 equals to f of minus 1, right? L1 is 1, f of minus 1 is 1, and L2 is also 1, which means what? At this point I have continuous case. Continuous is there. Second point, have a look on this side. Have a look. The second point, which is the second point? At 0, sir. When x is equals to 0. Please check. What is my L2 simply? L2 is simply minus 1. How come, sir? From here, minus 1. What about function at 0? Function value at 0 is what, bacha? Minus 1 again. Check the equality here. Minus 1 again. Now look for L1. Look for L1. For L1, I'm going to do what? Put x as 0. So minus 2 times of 0 minus 1, so 0 minus 1, so minus 1. What I'm getting? Please check. Minus 1, minus 1, minus 1. What I'm getting, bacha? L1 equals to L2 equals to f of 0, which means what? Which includes what? This point is also continuous. So what we are getting? Please see this. Let me summarize it. We had two critical points. At both the points, we got the function to be continuous only. It means what? It means no points of discontinuity. And a बढ़िया question. Fun, right? After getting the 2 points, 2 critical points like this, we have proved that there is actually no point of discontinuity. Fortunately, okay, so that's what, sir. Why can't we say in the beginning? How can we say, bacha? We have to find it, right? No other choice that we have. So I hope you can understand this. Okay, please have a look. Yes, from the beginning, one more time. Moving on to differentiations now. Okay, this is simpler than continuity, right? I also felt that way when I was a student. No, I felt differentiation is easier than continuity. Yes, sir. Let's see. Chaliye. Differentiate the functions with respect to x. Okay, I have to use what here? Please tell me. I have to use combination of product rule and chain rule. Let's see. Differentiate, sir. Derivative of this cos of x cube times sine square x power 5. Please check. First let me do it for this part and keep sine square x power 5 as it is. Sine square x power 5 I have kept as it is. I'm doing for cos. I'm going to get what? I'm going to get minus sine x power 3. Is it enough? This is the end of product rule. Comes the chain rule now for x cube. How much is that going to be, bacha? 3x square, sir. Right? Now this is enough. This is done for the first part. Plus sign will come. Right? The formula is what? U dash v plus uv dash. Right? Right? Okay. Now plus what? I'll keep this time cos x cube as it is. Cos x cube as it is, and I'm going to differentiate what? This part. Differentiate sine square. If I do that, please check on this side. 1 second. I'm going to write over here, bacha. I'm going to write over here. Okay, I'll need more space. Multiplication continues over here. So I've kept cos x cube as it is. I'm going to differentiate this. First, I have to do what? The polynomial part. Sine square is there. So 2 sine x power 5. Is it over? So product rule is over. Chain rule continues now. For sine we will do. There are 3 functions over here. First is power. Exponential function. Sorry. Power is 2, right? Not exponential function. Polynomial function is there. So polynomial I've did 2 sine x power 5. Next what is going to be trigonometric function. So it will become cos of x power 5. Last bacha for x power 5 will do. Last for x power 5 we will do cos of x power 5, and for this I'll get what? 5x power 4, sir. This is end. Okay. Now can I simplify this? I can see, I can take here, I have x power, no, not this. This for operating on sine, right? This over here is operating on sine, right? So no, I can't take this common, but I can take this common, right? X square. Here I have x power 4. So let's take it common and see what are we getting. So I take, anything else we can take common, sir? No. So what are we getting? If I take x square common, this term will become what? Minus 3, please check. 3 into minus sine. So minus 3 sine square x power 5 into sine of x cube. For the first term, minus 3 and sine power x cube is left, sine square x power 5 is left, plus sine over here. First, what is left, bacha? 2 into 5, so 10. Okay. X power 2 is left. I had x power 4. Now I've taken x square common, right? So I have what left? 10x square. Now what I'm left with? Sine x power 5. Please check. Sine x power 5. Okay. Please don't take it common. This is sine square x power 5. Okay. I can take it common, but this is sine x power 5. Okay. Cos x power 5 times what? Cos of x cube, sir. Please check, this is also there. Okay, this is also there in the multiplication, sir, with this whole term. So cos of x cube, my final answer. Have a look. I know it looks lengthier, but that's what it is. Can't help it, bacha. Okay, prove that the function function defined as fx equals to mod of x minus 1 is not differentiable at x equals to 1. Kar lete hain. Let's define at x equals to 1. This point is very, very important. Let's write this over here. This point is very, very important. Okay, this is the critical point, right? Write the function fx equals to, at this point, x greater than equal to 1, x less than 1. X greater than equal to 1 and x less than 1. For x more than 1, bacha, what will happen to this? Tell me here. Take 2. 2 minus 1 is how much? 2 minus 1 is 1, sir. So positive. Means for x more than 1, this thing will open with a positive sign. So remains like this, sir, x minus 1. Hana? What about before 1? Before 1 will be negative, sir. If I take 0.5, it will be negative, sir. This will open with minus sign, sir. So what I'm getting, please check. I can write this as 1 minus x. Hana? Minus and minus will become plus, so 1 and minus x. So I can replace all of this and write simply as 1 minus x. Okay? But I'll not write it away, I'll write it on this place. So 1 minus x. This is a function definition. Can I differentiate it also? Now let's define what? Let us define derivative also. Same condition. If you differentiate this part, x will be 1 and minus 1 will be 0, right? For this part, 1 will be 0 and minus x will be what? Minus 1. Please check what is my left hand derivative value. Okay, when x is equals to 1, left hand derivative at x equals to 1. Please check here. Left hand derivative means this part, so minus 1. What's the right hand derivative, bacha? At when? At x equals to again 1. It's going to be simply 1, sir. Going to be simply 1, sir. Now we can conclude from here that left hand derivative is not equal to right hand derivative. So we can say what? So not differentiable at x equals to 1, sir. Not differentiable at x equals to 1, sir. We got it, no? Left hand derivative is minus 1, right hand derivative is plus 1. Got it? Chaliye. Sir, I move on to question number 11. I can. Let us do it. Question number 11 states that dy by dx को निकालना है. We have to find dy by dx provided y is equals to sine inverse of 1 minus x square upon 1 plus x square. Okay. X lies between 0 and 1. Okay, sir. Okay, sir. Sir, so difficult, sir. Is it? Let us see. Let us see. Looks complicated, but I don't think it is. So this is a function given as sine inverse of 1 minus x square upon 1 plus x square. Take x as, whenever you see this form, take x as tan theta. You'll have fun. X as tan theta, sir. So please check. 1 minus tan square theta upon 1 plus tan square theta. Sir, isn't this going to be, sir, cos theta? Sir, mistake again, sir. Cos 2 theta, sir. Not cos theta, no, sir. Yes, bacha. This is going to be cos 2 theta. Okay. So replace this whole thing by what? Y equals to sine inverse of cos 2 theta. Sir, no difference, sir. I cannot operate sine on cos. How will I operate sine inverse on cos, sir? Still, no, you didn't solve the problem. Didn't I? Please check. Sine inverse of pi by 2 minus sine 2 theta, right? Yes? Okay, no. Excuse me. Okay. Sine of pi by 2 minus 2 theta, right? Yes, now it is okay. Sine of 90 minus theta is what? Cos theta, no? Yes, sir, it works. Operate now. Sine and sine inverse. Cancel the effect. What is my result going to be? Sir, y equals to pi by 2 minus 2 theta, sir. Excellent. What is theta value? X is tan theta. What is theta value? So theta value is tan inverse of x, sir. From here, theta value is tan inverse of x, sir. I can understand that, sir. Great, sir. Put it here. Y equals to pi by 2 minus 2 times of tan inverse of x. Differentiate now. dy by dx equals to 0, sir. How come 0? Pi by 2 is a constant. 0 minus 2 times of tan inverse differentiation 1 plus x square. What is my final answer? Final answer है minus 2 upon 1 plus x square. Have fun. Done. Problem is done. Extremely simple question after the substitution. If you don't know the substitution, then difficult. Substitution if you know, simple problem. है ना? Okay, sir. Let's move on, sir. If you said so. Question number 12. Again, we will have to use substitution. Let us see how can we use substitution over here, bacha. My priya bacha. Y equals to sine inverse 2x 1 minus x square. Sir, looking at this, something has to be sine or cos, sir, because 1 minus x square will make it as cos square or sine square. Root will cancel. Yes, you are right. But first take sine inverse on this side. It will become what? Sine y equals to I don't need to take the sine y on this side. Forgive me, I made not a mistake, but I don't have to. Okay, please have a look. So simply substitution, sir. I forgot substitution, sir. Substitution, I said that I know that you know, but I forgot. Sorry. Take x equals to sine theta, sir. Okay, sir. Let's see. 2 sine theta, sir. X is sine theta, no? So 2 sine theta, sir. Root of 1 minus sine square theta, sir. Oh, yes. That's what you were thinking, and even I thought the same thing, right? What is this, bacha? 2 sine theta cos theta, sir. Cos square root is cos theta. This is a formula, sir, for... Sir, you are always wrong. Sorry. Sine 2 theta, not cos 2 theta, sine 2 theta. This time no problem, sir. So I got it basically, what is given in the root over here, so in the bracket over there as sine 2 theta. So now my problem becomes very simple. Y equals to sine inverse of sine 2 theta, getting the answer to be y equals to simply 2 theta. Okay, what's theta going to be, sir? 2 times of sine inverse of x. How come, sir? If x is sine theta means theta is what? Sine inverse of x. है ना? Yes. Differentiate कर लेंगे dy by dx to like this. Sine inverse differentiation is going to be 1 minus x square. Don't ask why, I gave you the formula sheet right away. Final answer. Simple. That's the domain, right? For x, that's the domain. Chaliye, moving on. Question number. I hope this is clear, right? Simple question, not difficult, simple problem. Okay, but having a good level, okay, means substitution means it makes your mind think or tick. That's a good thing. If you're very settled, comfortable, then it's not a good thing. Okay, get out of your comfort zone, do something different. That's why substitution methods. Okay, sir, y equals to sec inverse of 1 upon 2x square minus 1. Sir, isn't the same question? No, not the same. We'll have to use a little bit different approach. Please check. This time you take sec inverse on this side. Then I get this as, sir, sec y equals to 1 minus 2x square minus 1. Okay. Sir, 1 upon cos y, no sir, equals to 1 upon 2x square minus 1. So, sir, we know that cos y will be what going to be? 2x square minus 1. Now you take cos inverse on the other side. Cos inverse of 2x square minus 1. Sir, what's the point? Still you got cos inverse, sir, and there's an x inside. Can you not see the formula right now? I know you can see the formula. Yes, all of you can see the formula. Let me know, sir. Yes, I am able to visualize the formula in the comment section. Comment in the comment section. Yes, sir, I can able to. We see the formulas of cos inverse, sin inverse, all operating on this condition, which is 2x square minus 1. Take x as cos theta, no sir. So 2 cos square theta minus 1 is what, sir? Cos 2 theta, sir. Right. Put it here. Cos inverse of cos 2 theta. Job done, sir. Simply 2 theta. Y equals to what, sir? 2 times of cos inverse of x, sir. Simply what is the derivative going to, sir? dv by dx. dy by dx is going to be 2 times of minus 1 upon 1 minus x square, sir. So final answer, if I have to write it over here, please check, Madi. It's going to be what, bacha? dy by dx minus 2 upon 1 minus x square. Final answer, had fun. Yes, sir. Simple problem, right? Great. आगे बढ़े. Okay, चलिए. So this is simple. Substitution is over. Question number 14. Can a question get simpler than this? But I know few students, by just looking at this problem, sir, lot of terms are there. Dot. There are only 5 terms. X equals to 1, 2, x equals to 5. There are 5 terms. Dot doesn't mean every time is binomial theorem. Okay, only 5 terms. Please have a look. No, why I'm saying this, because when I was a student, no, I used to think that way. Okay, but when I become a teacher, there's a different approach. Okay, let us see, bacha. E power x, I can take the function to be plus e power x the square plus dot, or I can write this e power x power 3 e x power 4, right? Excuse me, let me write here as 4. Do not punish me for writing 4 e power x by power 5, है ना? Differentiate कर देंगे. dy by dx. Question is simplest, sir. E power x remains as it is, sir. Sir, e power x square will remain as it is. Then x square differentiation chain rule, sir, will become 2x plus e power x cube will remain same, sir, and differentiation will be 3x square. Excellent. Plus, for this part, e power x, whatever it is, sir, e power x, whatever it is, will remain as it is, and differentiate what? Chain rule, what? X power 4. You're going to get what, sir? 4x cube, sir. Yes. Same way, e power x plus 5, please check, will remain as it is, sir. And differentiate x power 5 with chain rule, sir. So 5x power 4, hai na? My final answer. If you want, you can take e power x also common, but don't have to. E power x, if there is an option given like that, you can take an. This question can be asked in option also. Simple problem. Okay, you can solve this without putting a pen and paper. Okay, in your mind also you can solve this question, right? Exponential function will remain as it is. You have to apply the chain rule for the power form. Okay, great. Shall I move on? Yes, question number Question number 15. Have a look. Differentiate the following with respect to x. Okay. कर लेते हैं. Right here, y equals to cos log of x plus e power x. So we have to use what? Algebra of differentiation once again. For cos, minus sign. Do not hesitate. Whatever it is remains as it is. Now comes the magic. Till here, simple. Now what I have to do? For the bracket inside. For log x, 1 by x. For e power x, same, sir. This is my answer, sir. Can a question get simpler than this, sir? Yes. If you want, you can simplify this as, x e power x plus 1 upon x, my sign here, sine of log x plus e power x. If you want, you can write in this step. Otherwise, the answer is correct. Okay. Have a look. Chaliye. Question number 16. Now comes your questions which has application of differentiation in it. Means you have to use not derivatives, not AOD, just advanced differentiation we have to take. You have to use some substitution. You have to use some application of logarithms. Let's have a look. How can we solve it? Take the function again. First step remains same. Define the function. Y equals to, my root है x minus 3. Doesn't mean the question is difficult. Simple है. Simple question only. Right, sir? Sir, correct, sir. Okay, sir. Plus 4x plus 5. The square on both sides. A square on both sides, sir. If I do that, what I get, bacha? I get y square over here. Okay, y square over here equals to, this will be gone, right? The root is gone now, sir. The root is gone, sir. Happy, sir. Okay, sir. Correct. This part is okay. Now take log on both sides. Take log on both sides. If you do that, please check. Log of y square equals to log of this whole thing, x minus 3 x square plus 4 upon 3x square plus 4x plus 5. Now think about it. Log of a into b is log of a plus b, and log of this whole thing by this thing. I have to take what subtraction means. I have to add log of this plus log of this, and with the difference of log of this on the right hand side. What about left hand side? This 2 will come in front. The power of the y will become coefficient of log. So 2 log y equals to log of what, bachcha? Log of x minus 3 plus log of x square plus 4 minus, now for the denominator, minus log a by b is quotient rule, not a differentiation for logarithm. Okay, log of 3x square 4x plus 5. Now you're going to differentiate. Now the fun part starts. Differentiate now. For this side, what I have, 2 is a constant. 2 is a constant. For log y, sir, 1 by. Is it over, sir? Yes, sir. Log x was 1 by x. You did for x, it was 1. But for x, it was 1. Because differentiating with respect to x. When you differentiate x with x, 1. Great. What y with x, you differentiate, what are you going to get? dy by dx. So I'll have what here? Do not forget this. Okay? Since you're differentiating y, you have to write what? Differentiation of y with x. If it was log of x, no, you don't have to worry about it. But since it is y, so dy by dx will come. Over here, 1 upon x minus 3, and do for x going to be what? 1, sir. Chain rule. Please check. Plus, for this part, 1 upon x square plus 4. Chain rule for x square. For 4 it is 0. For x square going to be what? 2x, sir. Last, minus 1 upon 3x square plus 4x plus 5 बच्चा. For 3x square, sir, 6x, no? For 4x, simply 4. For 5, it is 0. Okay, right? Let me write this whole thing on the next slide. 2 by y dy by dx equals to, what is it? 1 upon x minus 3. So 1 upon x minus 3. Okay. 2x upon x square plus 4 plus 2x upon x square plus 4 minus 6x plus 4 upon 3x square plus 4x plus 5. Yes. Now I want to find what value. I want to find the differentiation of this. If I've taken this as y, I'm looking for what value? I'm looking for my final answer as this. So take 2 by y on this side. I get what? I get this as dy by dx equals to 2 will come in denominator. So y 1 by 2 here. 2 in the numerator comes here on the other side. 1 by 2. And y will go up. So y will come as what, sir? Same thing, the big one. If you're confused about this, have a look. This y will go in other side. No, becomes multiplication, right? What is the, if I write here like this y, no problem. Okay, let me write this part. X square plus 4 was there. Yes, sir. But what is y value? Y value, I've taken this, the big root. So write the root again over here. For this question, I'm writing everything. For the next question, I will not write all the steps. Okay, you have to write when you are solving it. Don't, be like me. Okay, you have to write because you have to get the marks. Okay, bacha. Clear, bacha. X minus 3, x square plus 4, whole thing divided by 3x square plus 4x plus 5. Same thing is there for y. Same thing is there for y. This step is my final answer, sir. Looks big, but what can I do? This is what it is. This is my final answer, sir. dy by dx equals to 1 by 2 root of x minus 3 times x square plus 4 upon 3x square plus 4x plus 5, 1 upon x minus 3, 2x upon x square plus 4 and 6x plus 4 in the minus side upon 3x square plus 4x plus 5. है ना? आगे बढ़े. Let's have a look first. Let me show you once more if you want to have a look. Okay. Next going to be what? This slide, and I'll move on to question number 17, sir. An excellent question. Be patient with me because I have to do the differentiation for all the 3 parts. So be a little bit patient with me. Okay, let me take this function to be function as p. What we're looking for? We're looking for this value only, sir. dy by dx looks very simple, sir. Why the complication? What can I do? Question is like this, sir. Q and this is r. I know many of you are very happy that I'm doing this question because when you were solving this in school, in your PU college, you got stuck, right? So you're very happy that I'm doing this question over here. Anyway, great, no problem. So if I have to differentiate this whole thing, I hope what is my answer going to be, bacha? Is going to be, sir, dp by dx plus dq by, for the second function is q, so dq by dx again plus what, bacha? dr by dx equals to what, bacha? 0, sir. Because a power b is a constant, so 0, sir. Okay, great. So now let me start with the p. Once I do for p, q, r, I'll put back the values over here and find finally dy by dx. Don't worry about it. Let's see. P is y power x. Take log of p equals to log of y power x. Bring x over here. So log of p equals to x log y, sir. X comes as the coefficient. Differentiate now. 1 by p. For log p, 1 by p. Is it over, sir? No, of course not. dp by dx, sir. dp by dx, sir. What about this side? I have to use what, sir? I have to use the product rule. So keep x as it is. Do for log y, 1 by y dy by dx na sir. Correct. Next step, plus sign, keep this time log y as it is. Do for x sir, simply 1. For x simply 1. So find dp by dx value from here. So dp by dx is equals to p times of, I'm taking this p on the other side, x by y, right? X into 1 by y is x by y dy by dx plus log y. First one is over. First one is over. dp by dx formula value I got. Okay, I'll put the value of p later, but right now I got the dp by dx value. I have to do what next? dq by dx. Please have a look. dq by dx. So let's take q now. Okay, q now. What is going to be q? X power y. Take log now. So log q equals to, if I take directly now this time, y will come in front now. So y log x. I can take, right sir? Please check. Power was x here, comes as the coefficient. Here power is y, comes as the coefficient. Agreed? No? No problem. Differentiate it sir. 1 by q. Log of q is 1 by q. But not enough sir. Chain rule dq by dx sir. Again what? Product rule sir. Keep y as it is. For log x I'm going to get what? 1 by x. For log x I'm going to get 1 by x plus. Keep log x as it is. For y I'm going to get what? dy by dx. So what is the value of dq by dx? Check, check, check sir. I'll bring this q on this side. So q y upon x, right? Y into 1 upon x is what? Y into x. And what is this? Log x dy by dx. My value number 2. ठीक है? This is okay. Value number 1, 2. So check here. I wanted dp by dx, dq by dx I got. Next I have to find what? dr by dx. What is r? X power x. Check here. What is this going to be? R equals to x power x. Take log sir. Log r equals to, x will come in front. So x log x, right? X log x. Now differentiate. 1 upon r dr by dx equals to what bacha? Apply here product rule. Keep x as it is. Bring log x differentiation as 1 by x plus. This time what are you going to do? Keep log x as it is. What will be x for? For x will be 1. What I'm getting this now? Please check. I'm getting dr by dx is equals to what? X and x cancels. So 1 plus, what is this left here? Log x times what? R sir. Now time to substitute the values that I got. Please have a look. Okay. Okay, great. Chaliye, so let's see what I had the case. I had the case to be dp by dx plus dq by dx plus dr by dx equals 0. From here. So this part, p times of x plus x by y, I have to write whole of this thing. So let me write it here. P times of x by y dy by dx plus log y. dy by dx plus log y. Okay, first is over. Second step, plus for dq by dx what I'm getting, please check. Q times of y by x again. Okay, q times of y by x. So q times of y by x. All right, what is it? Plus log x dy by dx plus log x dy by dx. This also is over. The last one, dr by dx, please check. Okay, that I have already here only. So right here, r times of 1 plus log x equals to 0. Now I want to find what value? I want to find the value of dy by dx. Please check. Means I have to take something common here to make some result for us. So wherever I have dy by dx, I'll take that term common here and here. I have any more places? No. So I'll take that out like this. Please check. From the first term, what is left in this case? P times of xy, P times of xy. This is gone. This step is gone. Over here, plus sign is there. What I'm getting, if I take dy by dx common, q times of log x. है ना? Have a look, sir. Have a look, sir. Yes, sir. Please have a look. Please check. If I take dy by dx common from here, what is left now? X plus y is x upon y is left. Times p is also there. So p into x plus y. So x upon y. For this case, I'm taking again dy by dx common, sir. So log x into q. So log x into q. Dy by dx term is gone now. Rest term I'll expand now. Again, p times of log y. So I write it here. P times of log y. This term, this p with log y. Check the other terms. Q times of y by x. So q times of y by x, and over here this whole thing as it is. So plus r times of 1 plus log x equals to 0. Now in the next slide, I'm going to do what? I'm going to take these terms on the other side. Please check this term, this term, this term on the other side. So we'll keep it like this. dy by dx. What is there over here, bacha? pxy plus q log x plus q log x. This side is gone. Taking rest of the terms on the other side. P log y, q y by x. So will become negative p log y minus q y by x minus q y by x plus this will also become minus. So minus r times of 1 plus log x. है ना? Anything else is there? No. Now put the value. So I'll put this here. So whole thing I'll write over here. Minus I'll take common now. So p log y plus q y by x plus r 1 plus log x, close the whole bracket, divided by what I'm getting on this side, p xy y plus q log x plus q log x. Now put the value of p. What was the value of p here? Please check. Put the value of p, q, r again. P, q and r. P was x, y power x. This was x power y and this was x power x. Have a look. Yes. Substitute it back. Okay. So what I'm getting over here, I'm getting dy by dx equals to, minus sign is there outside. P is what? Y by x, right? So right here, y to the power x, not y by x, y power x. Forgive me, log y plus q. What's q, bacha? X power y. X power y. Great. But you also have, sir, x in the denominator, right? I can write it as x power y minus 1, na? Please check. Q is x power y, but I also have x over here. I can write it as x power y minus 1, and this whole thing multiplied with what? With y. I don't have to write x now. This x in the denominator is what? Denominator, right? So x power 1 can be subtracted in the power. So y minus 1 I've written it here. No problem. Plus r. What is r going to be? X power x. Please check. So x power x, okay, and 1 plus log x. 1 plus log x, so close this whole bracket. Divided by the last step, p again, y power x is there, right? I have also y in denominator, so y power x minus 1 I can write. Y power x is there, p. I also have p in the y in the denominator, so y power x minus 1, whole thing multiplied with x. What is going to be q, bacha? X power y. So write it here, plus x power y log x. My final answer is this. Have a look. बड़ा है थोड़ा सा, I understand that, but what can I do? The question is like that. I told you, very good question. Please have a look from the beginning. Okay, I hope this is visible to you. Yes, yes, great. Have a look. So we did for p, q, r individually, got the dp by dx, dq by dx and dr by dx, substituted back in the condition that I got. from the differentiation of the given equation. Okay, after substitution I have to make some changes to find the value of dy by dx. I got the result to be this, y power x. There's a minus sign over here, of course. Okay, please have a look. Okay, this part is clear, right? X power y was there, bacha, and x was in denominator, so I took, I can take the minus sign, no, for the exponent. Yes, chali. So once again, from here, have a look. Question number 18. Differentiate the function x power x cos x plus x square plus 1 x square minus 1. I have to do this thing again, sir. Sorry, but I have to do it. P and Q. Sir, not sorry, sir. Thank you that you're doing it, right? We don't have to do it ourselves. You have to. After learning from you, have to do it from your side also. Let us do it for the first step. Please take here x power x cos x. Take log P equals to x cos x log x. Whatever is there will come in the what? Coefficient of log. Differentiate 1 upon p dp by dx equals to what? I have to use what? Product rule now for 3 terms. So first I'm going to do for x. For x I'll have 1 and cos x log x will remain same. Next what? I'll do for cos x. So I'll have what? Rest as it is. So I'll have, I'll write it over here. I'll write x log x as it is. Okay. And for cos x I'll have what? Minus sin x. Last I'll do what? I did x, I did cos x now. Now I'm going to keep x cos x as it is and keep or x cos x as it is and differentiate what? Log x. So write it here, x cos x as it is and differentiate log x is what? 1 upon x. Chali, xx gone, sir. So what I'm getting over here, 1 upon p dp by dx equals to what? Equals to from here cos x log x. Cos x, okay, I can't write it on this side. I'll need more space. So let me write on the other side. So 1 upon p dp by dx equals to what, bacha? Cos x log x. Cos x log x, okay, plus, okay, minus sign will come. There's a minus sign here. So minus x sin x log x minus x sin x and log x, and with this last one plus simply cos x. Simply cos x. Okay, this is the dp by dx. I want to find dp by dx, right? So write it here. Bring this p on the other side. What is p going to be? I'll keep it right now as it is. P times of this whole thing, cos x log x minus x sin x log x plus cos x. Okay, first one is done. Please have a look. First one is done, sir. First one is done, sir. Now moving on to second one, x square plus 1 upon x square minus 1. So take now q equals to this x square plus 1 upon x square minus 1. 1 second, bacha. X square minus 1, how will I do it? Please have a look. Take log again. Log q. If you do it for this side, what are you going to get? Log a by log b. So sir, I'll get what? Log of x square plus 1 minus log of x square minus 1. Yes or no? Yes, yes. Differentiate on this side. I'll get what? 1 by q dq by dx equals to what, bacha? Please check. 1 by x square minus 1, sorry, plus 1. Differentiate x square now. So it's 2x. What about this side? Sir, 1 upon x square minus 1. Again, I have to do what? 2x for x square. Okay. I can continue on this side. So 1 by q dq by dx equals to what, bacha? What I have, can you take? I can take 2x common, right? So 2x is common. What I have? 1 upon x square plus 1 minus 1 upon x square minus 1, right? Please check. Yes, same thing is over here, right? Great. So write this 2 times of x. Take the LCM. X square plus 1 x square minus 1. So x power 4 minus 1, right? Correct, now? Please see. A plus B, A minus B. A plus B, A minus B is what? A square minus B square. So x square, the whole square will be what? X power 4 minus 1 square is again what? 1 only. So x square minus 1 to make equivalent fraction plus x square plus, oh no, not plus, bacha. Sorry, there's a minus sign, no? There's a minus sign, sir. So minus x square minus 1, okay? I can cancel something over here. Gone. What I'm getting? I'm getting this as minus 4x upon x power 4 minus 1. But I want to find the value of dq by dx. Please check. This is going to be what? Simply q times of minus 4x upon x power 4 minus 1. What is q value? Q value is x square plus 1, right? Or minus 1 plus 1 upon x square minus 1, okay, times minus 4x upon x power 4 minus 1. You can cancel this. Please check. This you can cancel, right? With this, what are you going to get over here? X square minus 1, same thing. A plus B is here. If you cancel a square minus b square with that, you're going to get a minus b. What's my answer going to be for dq by dx? Please check. My dq by dx will be, bacha, what? Will be simply, sir, minus 4x upon x square minus 1 the whole square, right? Same thing is over here, x square minus 1 and x square minus 1, so whole square. This is my answer. Okay? This is my answer. Okay, great. So now have a look. So if you want to have the final answer, you have to add both of them. That's all. So if you want to write the final answer, no, you have to add this dp by dx plus dq by dx. Please check. This is the dp by dx from part 1, this part 2. So add them, please. I don't have enough space to write it over here. Okay, I can write it on this side, but still you can add it, no? Cannot add it? You can add this together and write it down. Okay, but just replace p as this whole thing, x power x cos x. Okay, you can do it, no? You all can do it, right? Just write p as x power x cos x, then this whole bracket thing, and plus what? This thing, minus 4x upon x square minus 1 the whole square. That's your final answer. Just keep the pieces together and write the value of p in place of p in the first part. Okay, simple. You can do it. Can you do it? Yes. So let me move on to the next question. Okay, great, sir. Have a look from the beginning first. Question number 18. Okay, this completes the differentiation. Now will be what? Dealing with parametric form. Right? I've taken a very good question on the parametric form. Let us see. Let us solve them. I've taken, I think, 3 questions, right, on parametric form also. I've shown you in the index. How can we solve this question, sir? So we know this one condition, right? If I have, let's say, y as a function of what? F of t, and I have also x as a function of what? F of t. What I can do? I can write dy by dt, also dx by dt, and then what? My dy by dx will be equal to what, bacha? Will be equal to dy by dt upon dx by dt. So let's find dy by dt first. Okay. So y is what? Y is a sin t. So what is my dy by dt? A cos t. A cos t. Okay, great. Now what about x? X is this, sir. X is equals to a cos t. I don't have to write it, no? Again over this side. It's already written over here. Let me write the final answer. Dx, not final answer, like the differentiation directly. A constant kept outside. Cos t differentiation is what? Minus sin t for log plus 1 upon tan t, right? 1 upon tan t by 2, right? And then I have to do a differentiation of tan also. So I'm going to get what? Sec square t by 2. For t by 2, I'm going to get what? I have to do chain rule, right? For first for log, 1 by tan t. For tan, sec square. For t by 2, sir, 1 by 2. Now it's complete. Now let's have a look. A over here. Please check. Minus sin t is there. Great. Now what I can do, plus I'll write 1 by 2 over here, 1 by 2 over here, okay. Tan t by 2 I can write it as what bacha? Tan t by 2 sin t by 2 upon cos t by 2, है ना, right? What about sec? Sec will come in denominator, will become what? Cos square, what? T by 2. Anything else is there? Please check. I've taken already 1 by 2 over here. 2 is in denominator, right? So 1 by 2. Sec square t by 2 is what? Cos square t by 2. Have a look now. One of the cos will be cancelled with cos square. Okay, I'm left with sine and cos both. My step continues like this. So dx by dt is what? A outside minus sine t, please check, plus 1 upon what is that bacha? 2 sine t by 2 into cos t by 2. Remember this formula, sine t cos t with 2 sine a cos b, sorry 2 sine a cos a. What is that? Sine 2a, right? So over here I can write dx by dt as what? As what? A is outside minus sine t, okay, plus 1 upon sine t. How come, sir? Please check. Sine 2a, right? So 2 times of t by 2 will be what? 2 will get cancelled, no? Please check here. Sine 2a. So sine of 2 times of t by 2, no? 2 cancels. What is it? Sine t. That's why I've written the denominator as sine t. Okay? Chaliye. Take LCM now. Minus sine square t equivalent fraction plus 1 upon sine t. Simplified bacha. So a cos square t upon sine t, है ना? देखिए 1 by sine square is what? Cos square, no? So I got dx by dt. Now what are you looking for? d by dx is going to be what? Excuse me. dy by dt, dy by dt upon dx by dt. So a cos t upon a cos square t by sine t, a and a gone, cos t with one of the cos square is cancelled like this. I'm getting my dy by dx equals to, sine will go up, right? So sine t by cos t, okay, how much is that? Tan t. What are they asking? dy by dx equals to what? Tan t. Is it the final answer? I have to change the t also. Please check whether we have to change or not. Okay, without eliminating, right? Without eliminating means we don't have to remove the parameter. What's the parameter here, bacha? The parameter is t. The answer is what? dy by dx equals to tan t. Have a look. Have a look. Yes. Okay. This is it. Simple. Very simple. Any doubt, let me know. Any doubt, let me know in the comment section. Okay. Let me continue with the question now. 20th. I know this I will not do. This too I will not do, sir. Solve and comment your answer for question number 20. Okay, I can give you the answer. Answer should come as so then why are you giving the question to solve? I wanted to put an effort, bacha. I know you all are very honest students. I'm not kidding. Okay, because that's why you're here, no? You're here to put an effort, and those are people who are honest people. Okay, the answer is tan theta. If you get it right, right here, comment here, GIR, got it right, sir. Got it right, sir. Okay, great. Question number 21 can I do now? Yes, a very good question. Let's see. This is again on parametric form only. Okay, so x equals to a sine inverse of t, y equals to a cos inverse of t, so that dy by dx is minus y upon x. चलिए कर लेते हैं. Before that, let's just square it up. I don't like roots. I know you also don't like, right? I don't like roots that much. Square both side. X square equals to a sine power what? Sine inverse of t. This is what formula? A power x differentiation. Remember this? A power x differentiation, sir. Differentiate, bacha. 2x on the left hand side. X square differentiation is how much? 2x only, na sir. Yes, na sir. Okay. Acha, is it enough? No sir, not enough. Because what's the parameter over here? The parameter is t, sir. The parameter is t, sir. I have to write what? Dx by dt. Sir, but whenever it was t, dx, we did not used to write, no? Tx by dx. Because there the differentiation was what? With respect to variable x. We were doing differentiation with respect to variable x. Here what is the variable? We are differentiating with respect to t, sir. So dx by dt will be there. Sorry, but it will be there. You have to manage from here. A sine inverse of t will remain as it is. And what will come next to this? What is going to come next to this? Sir, ln A. Is it enough, sir? Good, no? No, bacha. Chain rule. This is just for a power sine inverse of t. Chain rule, sir. Sine inverse of t differentiation. Okay, sir. 1 minus t square. 1 minus t square. Simple, right? Not that much. Next what? Next what, sir? Next is going to be for dy. For y part, check here. So I'll write here now. Again, same thing. Y square equals to what, bacha? A cos inverse t. Okay. Differentiate now. 2y. So this is going to be coming because the parameter is t. So dy by dt equals to, please check. This will remain as it is. So a power cos inverse will remain as it is. But I have to add what? ln a divided by cos inverse differentiation going to be what, sir? There will be a minus sign here, sir, and whole thing will be 1 minus t square. Right? Okay. Now we are looking for dy by dx. Please check. Do one thing. Take this as equation number 1 and this is equation number 2. Now do what? Equation 2 by, divide equation 2 by equation number 1. Check the LHS side. I'm going to get what? 2y dy by dt divided by 2x dx by dt. Right hand side, please check. A cos inverse of t. How much is that, bacha? Please tell me. Okay. I'll write in the next step. That's all right. A cos inverse of t. A cos inverse of t. Okay. ln A. There's a minus sign, so keep a minus sign somewhere here. Okay. Divided by what? 1 minus t square. This is what? This is just the RHS of equation number 2. What about RHS of equation number 1? Please check. A sine inverse of t ln A divided by 1 minus t square as it is. Cancel, sir. ln A also is cancel, sir. What is left over here? Sir, 2 and 2 is also cancel, sir. Please check. Sir, y by x is left on this side. Y by x is left on this side. And this will become what, sir? dy by dt upon dx by dt will become what, bacha? Sir, dy by dx, sir. Great, something good is coming up now. Minus sign is there because of this minus. What I'm left with, a cos inverse of t upon a sine inverse of t. A cos inverse of t upon a power is not multiplication, it's in the exponent, sorry. So a is somewhere over here and a power sine inverse of t. Please check. What is a power cos inverse of t? Y square. This is a minus sign, of course. What about this? A power sine inverse of t? X square. This is equal to what? Y upon x dy by dx. Cancel here. Y. What I'm getting? Done. dy by dx equals to minus y upon x. We had to prove it, and so we have a look. Please have a look. I hope all of this is visible to you. Have a look once again on this side. Yes. Okay. Just few more questions, then we'll conclude the session. I know the question is getting lengthier. I can understand that, but I wanted to do all the NCERT important questions in one shot. Okay. A very important question. The questions you can expect in your any test or any examination from this category. If you solve all these 27 questions, I can guarantee that, and you can solve this without any trouble. Let's say you take the 27 questions. How can I take the questions, sir? Please join the WhatsApp channel, get the question paper, okay, the class notes, and attempt all these questions again. And if you're able to solve all these questions without any trouble, it means your concept is very clear. It means you are prepared for NCERT point of view. Then you can solve the PYQs also, and your chapter will be complete, sir. Okay, great, bacha. Have a look. 21, question number 21, over. Now we are moving to what? Second order derivative. I've taken again 3 questions over here also. Find the second order derivative of functions given by e power y x plus 1 equals to 1. So that this is also true. So let's do the derivative first. So I write it like this, e power y x plus 1 equals to 1, right? Differentiate, I can use here what? Product rule, okay? E power y will be what, bacha? I can differentiate now. E power y only, dy by dx will be there. But I have to write what? X plus 1 with it, okay? And what I'm going to do? Plus sign will come. Keep e power y as it is now in this time and differentiate x plus 1. For x I'll get what? 1. For 1 I'll get what? 0. Equals to 0. Okay, sorry. This is not 0. This step is 0. After differentiating it, I'm going to get this as 0. I just did my differentiation in that point of time only. Okay, so e power y differentiation as it is. Differentiate y, dy by dx, x plus 1 is kept as it is. Product, and we are using product rule. This time we're going to keep what? E power y as it is. For x we'll have 1, and for 0 we'll have, for 1 we'll have 0. Now write this, e power y x plus 1 dy by dx. I'm writing like this, rearranging this, nothing but e power y equals to 0. देखिए ध्यान से, e power y x plus into x plus 1, how much is that? 1, sir. So 1 into dy by dx equals to what? Bring this on this side, e power y, okay, minus e power y, okay, chali, great. All right, sir. Okay, e power minus e power y, if I get like this, okay, then I am having this as dy by dx equals to minus e power y. Differentiate again, differentiate bacha. D square y upon dx square will be equal to what, sir? It will be equal to differentiate of this minus e power y into what? Dy by dx again. What's dy by dx? Same thing. So minus e power y into what? Minus e power y. Please check. How much is that going to be? Sir, e power y the whole square. So what I'm getting my final answer as? D square y upon dx square is equals to what? Minus e power y is how much? Dy by dx. Final answer. Have a look. Proved, right? Correct. This is the answer. This is one of the answer. First part answer. Find the second order derivative. So minus e power y the whole square. Basically, what is this going to be? E power 2y. That's my answer. But they're also looking for this condition to be proved. We proved it over here. Right? Okay. Now moving on to question number 23, sir. Question number 23, sir. Again, question on second order derivative. Have a look. Okay. So y equals to, I have what? Tan inverse of x the whole square. Great. Now bring this over here. Okay, no, I cannot do that until unless I differentiate it. Let's differentiate it, bacha. Let us differentiate it, bacha. Okay. So if I differentiate, I'm going to get what? y1. Y dash is what? y1. D by dx is what? y1. You know this. This all means the same thing. y1, y dash or d by dx means the same thing, sir. In this case we are using y1, that's why I wrote it in this format. No other reason. Okay. Chaliye. y1 on the left hand side, 2 times of tan inverse of x, polynomial differentiation. Then for tan inverse of x, what I'm going to get? 1 plus x square. This is done. But we are also looking for y2, sir. Please check. Differentiate this side. I'm going to get what? Y2. This is equation 1, right? Differentiate equation 1 again. I'll get what? Y2. What about this? I have to use what? I have to use the quotient rule, sir. 2 constant, keep it outside. Differentiate tan inverse. 1 plus 1 upon x square. Sorry, 1 upon 1 plus x square. This I'll keep as it is. Denominator will be kept as it is. Okay. This is for what? Differentiation of tan inverse of x. Okay. Next what? A minus sign will come. This time I'm going to do what? Do the differentiation of 1 plus x square. How much is that? 0 plus 2x. Keeping tan inverse of x as it is. Dividing whole thing by 1 plus x square the whole square. Okay. Chaliye. Let me write it over here with some space. y2 equals to 2 times of, I can cancel here bacha. Okay, 2 times of 1 minus, please check, 0 plus 2x is just 2x, no? So 1 minus 2x times of tan inverse of x, okay, upon 1 plus x the whole square. 1 plus x the, so 1 plus x square the whole square, right? 1 plus x square the whole square. Okay, great. Now we have to put it in this condition. So let's take the LHS part over here. We have to verify this, no? We have to verify the statement. X square plus 1 the whole square times y2 plus 2x times of x square plus 1 the whole times of y1 equals to 2. So let's take the LHS part only. What is going to be this? X square plus 1 the whole square times of y2, right? What is y2 going to be from here? 2. This is y2, right? 2 times of 1 minus 2x tan inverse of x divided by 1 plus x square the whole square. This is just y2 part plus 2x x square plus 1 is also there. Okay, times of y1. What is y1, bacha? Please check from here. y1, please check from there. 2 times of, again, tan inverse of x upon 1 plus x square in the denominator. Now check. This is only LHS, okay? Only LHS, okay? Now have a look. This will cancel with this. Okay? Same way, this will cancel with this. Okay? What I'm left with now on the LHS side? Please check only on the LHS side. I have here 2 times of 1. So 2 times of minus 2x. So minus 4x tan inverse of x. Right? Anything else is left in this term? No, sir. Then comes the plus sign. Over here, 2x times of 2 tan inverse of x. Please check. 2x times of 2, 4x tan inverse of x with the plus sign. So 4x tan inverse of x. Can you see something? What is left? So LHS is equals to 2, which is equals to RHS. Hence what? Hence verified. Looks complicated, but it was very simple actually. Have a look. A very, very simple problem. Thana? Yes. Please have a look. Okay. Shall I move on? Yes. Question number 24 coming up again based on the same property of one more question on your second order derivative. So, okay. Let us do this, bacha. Let us do this, sir. Okay, I have taken some space so I can differentiate this x minus a the whole square plus y minus b the whole square equals to c square. Okay, great. Okay, differentiate now. 2 times of x minus a. For x I'll get what? Simply 1, so I write it as 1. Chain rule, right? This time 2 times of y minus b. What I'm going to get in this side? Simply, sir, y1, right? There's no y1. Okay, so right here dy by dx. How come, sir? First I have to use the polynomial function. Y minus b, 2 times of y minus b power 1. Then I have to do for y also, right? So dy by dx. This side is simply 0. This side is simply 0. So bring this, I can cancel this 2, no? Please check. this 2 is cancelled with 0, right? I can bring this 2 common and bring on the other side, will be 0, no problem. If you don't want to do that, just take whole thing on the other side and cancel with 2. So I can write this as y minus b dy by dx is equals to what, bacha? Is equals to, please check here, x minus a with the minus sign, x minus a with the minus sign, okay? And I'm getting this as dy by dx equals to what? Please check, minus x minus a divided by y minus b, sir. Y minus b, sir. Anything else? Yes? No. Okay. Chaliye. Now I want to do what? Second order derivative also. So let's do it here. D square y upon dx square. I have to use what, bacha? I have to use a quotient rule. First for numerator I have to do the differentiation. I'm going to get what? Please check. I'm going to get this as simply minus, sorry, not minus, I've taken already out, simply 1, right? Simply 1 times of, now do the second order derivative, bacha. How will I do it? Please check. 1 second. Yeah, d square y upon dx square. If I do it like this, I have to use what? I have to use the quotient rule. Take my sign outside, okay? I'll need more space, so let me just do this, okay? 1 second. I can do it on this side, bacha. D square y upon dx square equals to, please have a look, minus sign I'm keeping it outside, okay? For x minus a, if I do, I'm going to do what? Simply as 1. For x it is 1, minus a will be constant, so 0. Keep y minus b as it is, okay? Y minus b as it is. Now what is next? Minus sign will be coming. Keep x minus a as it is this time, and do for y minus b, it will be what? It will be dy by dx, sir. It will be dy by dx, sir. Okay, divided by whole thing as y minus b the whole square. Y minus b the whole square. Okay, great. Chaliye. So yes, x minus a as it is. Yes, correct. Chaliye. Now I can do what? Please have a look. D square y upon dx square equals to what? Minus sign y minus b, okay? Y minus b minus, I can write here like this, x minus a dy by dx, okay? I can write dy by dx value, no, from here. Please tell me. I can write the dy by dx value from here. So let's substitute that value. Okay, sir. Let us substitute this value. I'm a little messy. I'll try not to. So if I take check here, minus will make this as positive, okay? Numerator will become what? This x minus a and x minus a will become what? Whole square. How I'm doing this, sir? Putting this dy by dx value from here. If I take this as equation number 1, I'm using equation number 1 over here in this right side of the term. So minus will make this to be positive. X minus a the whole square. This is minus y minus b simply, okay? Divided by whole thing as y minus b the whole square. Let me repeat this step on this side. Now what I'm getting, d square y upon dx square equals to, minus sign is outside, okay? Please check, I can take the LCM right in the numerator. It will become what? Y minus b the whole square, making equivalent fraction. So y minus b the whole square, is it minus? It's, I think it's plus, right? Plus x minus a the whole square, everything divided by what? Y minus b, and this whole thing is divided by what? Y minus b the whole square. Please have a look. Please have a look. I'm just making equivalent fraction on this side. So it will become what? Y minus b the whole square. This will remain as it is, and this is the denominator. Now I can take this denominator down, so what I'm gonna get? Please check. Minus, what is this, bacha? Y minus b the whole square plus x minus a the whole square. Question itself. Please check. Y minus b the whole square plus x minus a the whole square is simply c square. So write it there. C square is the numerator. What about denominator, sir? Y minus b and y minus b the whole square. Sir, y minus b the whole cube, sir. This is the value of d square y upon dx square. Okay? Chaliye. Great. Now what I have? 1 plus this value, right? Okay, this is in denominator. So let's write this condition first. What we're looking to find? Okay, 1 plus dy by dx the whole square. 1 plus dy by dx the whole square. Okay. Power 3 by 2. The whole thing to the power 3 by 2 divided by d square y upon dx square. So minus, what is it bacha? Check here, c square upon y minus b the whole cube. Okay, this is the value that we are looking for. Okay, please check. What is dy by dx? Minus x minus a upon y minus b. So please, if I take the whole square, I'm going to get what? 1 plus x minus a upon y minus b the whole square, the whole to the power what? 3 by 2, and is divided by what? Same thing. Please check. C square upon y minus b the whole square with a minus sign. Great, sir. Okay, this is simple, right? X minus a, and this is not 4 minus b, looks different. What is this bacha? Y minus b. Okay, this is y minus b the whole square. How come this is whole square, sir? 1 second, let me show you. Okay, this is from the given statement bacha. Here this given whole square. So over here whole square, this is power 3 by 2. Power 3 by 2. Simple enough. Let's check now. Can I take LCM on this side? Inside only. Please check. I can take this LCM, will become what? Y minus b the whole square in the denominator will become what in the numerator? Multiply with 1. So y minus b the whole square plus, this will come as it is, x minus a the whole square upon what bacha? Y minus b the whole square. This whole thing is with what? Power 3 by 2 divided by what? Minus c square upon y minus b is the whole cube, right? Y minus b the whole cube, right? Okay, great. I have enough space, no problem. Good question. Now check here. If you see this is again going to be what? This is again going to be c square. This is going to be what? Numerator c square. So what I'm getting? C square upon y minus b the whole square, the whole thing to the power 3 by 2, sir, divided by this thing minus c square upon y minus b the whole cube. Y minus b the whole cube. Yes. Okay, now please check. I can write this statement over here again. C square upon y minus b the whole square. Okay, power what bacha? Power 3 by 2 whole thing by minus c square upon what? Upon y minus b the whole cube. Please check now. Very interesting. Power square can cancel this 2 and 2 over here. What I'm getting now? I'm getting this as c cube upon y minus b the whole cube, the whole thing divided by minus c square upon y minus b the whole cube. Right? We'll look at the question statement later, but let's see this. Cancelling it out. What I'm getting now? C cube minus c square. C cube upon minus c square. How much is that? Minus c. So my final answer, what they were giving, what they asked for was 1 plus dy by dx the whole square to the power 3 by 2 upon d square y upon dx square is coming as what? It's coming as minus c. This is the answer, right? It's coming as minus c. Have a look. It is coming as minus c. What are they asking in the question? Is a constant, this value is a constant independent of a and b, isn't it? Have a look. It's coming as minus c, no? So this result that they gave is a constant independent of a and b. Please check here. Please check here. Same thing is given here. Yes, it is a good question. Okay, I think it is from the miscellaneous category also. So it's a very, very good question. Please solve it. If you're not getting it in one way, solve it again and again and again. Okay, I know you can do it. I know you will do it. Okay, I believe in you. Please solve, bacha. All of my students will solve this question at least 3 times. Okay, you can solve 3 times. One time you'll keep guessing, sir, okay, this place I made mistake, how is this place coming like that? Second time you'll be confident. Third time you'll get it right without any break in the solution. Question number 25. If cos y equals to x cos of a plus y with cos a not equal to what bacha? Or plus minus 1, prove that this condition is true. Chaliye, do one thing, find the x value. Cos y upon cos of what bacha? A plus y, right? Equals to x. We're looking to find what value? dy by dx value. Means I have to differentiate with respect to what value? With the variable x. Differentiate now. I'll get this as 1. So this will become what? Quotient rule I have to use. Quotient rule. Keep cos of y differentiation. You're going to get minus sine y. dy by dx will be there. Correct? Correct? Check here. Cos y differentiation is minus sine y. Y differentiation is dy by dx. Okay? Keep this cos a plus y as it is. है ना? है ना? Now minus sign will come bacha again. Differentiate what? The denominator. Keeping this numerator as it is. So I'm going to get what? Please check. Cos y is kept as it is. Differentiate now. Denominator. Again what I'm getting? Minus. How much is this? Cos will become what? Sine a plus y. Is it over? No sir, I have to do for y again. So dy by dx. Now it's over. This is the only LHS. What about RHS sir? Equals to 1. Equals to 1 sir. Have a look. Okay. Chaliye. I will solve it on this side now. I need more space because the question is a little bigger. So what I get? Minus sine y. Can I take dy by dx common now? Let me write everything again. So I get what? Minus sine y. Okay. Acha, one thing I forgot. That's why I said I had to use more space. It's the quotient rule, right? So divide everything by. Divide all of this by what bacha? Cos square a plus y, and then write this equals to 1. This whole thing is equals to 1. Looks confusing. Can I write this again on this side? I'm gonna write this whole thing again on this side. Please have a look. Sin y dy by dx. I will not change the order also, just to make simpler things for you. And cos of a plus y bacha. This is it. And minus sign is there. So minus cos y. Cos y. How much is that? It's going to be minus sign is there, right? So minus sine of a plus y, okay, and dy by dx. So right here, I'm gonna erase this part. I don't need this anymore. I'm writing this thing again, right? So dy by dx. Please check. Dy by dx. Okay. Whole thing divided by what, bacha? This whole thing divided by what's the cos square of a plus y. Okay. Now I will erase this side also completely. Don't worry. I'll show you again how I did the differentiation. No worries, sir. I'm here. Don't worry about anything. How the steps will be, what to write, what not to write. I'll take care of all those things. I just made a calculation mistake there. I think this space will be enough. I'll show you again. So please check. This has to be there. X equals to what? Cos y upon cos of a plus y. Use the quotient rule. So cos y, if I'm doing, cos y is minus sin y, then what? Differentiation of y will be dy by dx, keeping cos a plus y as it is. Now quotient rule, so minus sign will come, keeping cos y as it is. Differentiate what? Cos of a plus y will give me what? Minus sin of a plus y. I have to differentiate again a plus y, a will be 0, y will be dy by dx. Differentiate by square of, so divide by square of cos square a plus y. X differentiation is 1, sir. Bring this over there, sir. Okay. Bring the whole of this over there, sir. Please check now. So I'm gonna get, I can take dy by dx common, no? Please check. It's common, right? Excuse me. It's common. What is left over here? Minus sin y cos of a plus y. Okay, okay. This minus and minus will become what? Plus, sir. So plus cos y sin of a plus y. I've taken dy by dx common. This will become what? 1 into what? Acha, 1 into I can do, right? So don't write 1, just write cos square ay. Cos square a plus y. लिख लेंगे. Any problem? No, right? I'm looking for dy by dx value, no? So before that, I can make transformation over here. Please check this formula. Sine of c cos of d. Sin c cos d. What about this? Cos c and sin d. So sin c cos d and cos c sin d. Here minus sin, here plus sin. Is a formula of what? Sin of c minus d. So sin of c minus d means what? Please check. a plus y minus d. D is how much? Y, right? Great. Equals to what, bacha? Equals to cos square of a plus y. Have a look. Y gone. I can write it over here again. dy by dx times what? Sin a is left equals to cos square of a plus y. Have a look at this last step. Only sin a is left because y and y is cancelled, right? Okay. I want the value of dy by dx equals to what, sir? Cos square a plus y upon sin a same thing is written over here. Cos square a plus y upon sin a for dy by dx. We have to prove this and we got this. Cos square of a plus y upon sin a. Have a look again from the beginning. Yes. Yes. What is the one thing we did? Find the x value. Why? Because we have to find what? Dy by dx. So the variable we have to differentiate with is x. Okay. That's why I took x on one side and then we use the quotient rule. Simple one step. Only one approach is there. Then you have to use the formula of sin a plus b, or sorry, sin a minus b, or sin c minus d in this case. Okay. Great. Moving on. Have a look. Okay. Question number 26. Can a question get simpler than this? Of course not, sir. Have a look. I'll show you. First, forget about dy by dx. This is dy by dx, right? First take y. Solve this determinant for y. How will you solve it? I will not write fx, gx, hx. Okay, I'll write simply f, g, h. I'll write simply as f, g and h. You know, f and g and h are function in x only. So if I solve for f, first row I'm using the first row to solve the determinant. F times of what I'm going to get? M into c, n into m. So mc minus nb. mc minus nb minus g times of what, bacha? G times of lc. Please check. G times of lc minus an. Right? What else? What else now? Please check. The last one will be plus h. Plus h. How much is that going to be? lb minus am. So lb minus ma or am, whatever it is. Okay. Now I want to find different derivative of this. Find derivative of this. Y dash is going to be what? Constant, right? So keep this f dash. If I want, I can write it as x also. F dash of x times of mc minus nb. Minus again here g dash of x times of what? lc minus an. Okay. Plus h of x times of what? lb minus ma. So first determinant I have solved and then the differentiation also. Please check. Done the differentiation also. Solve this, got the differentiation of y as y dash. What is y dash? dy by dx, right? I'm going to use the second one now. They have given this dy by dx. Nothing but simply y dash is given as, please check what they've given. F dash, g dash and hx. So I'll write here f dash x, g dash s and h dash x. Okay. L, M, N, A, B, C. L, M, N, A, B, C. Okay. Let's solve this also. Determinant f dash of x times of what I'm going to get? MC minus NB. Please check. MC minus NB. NB is the first one, right? Please check. I'll cross check at the same time. MC minus NB. F dash of x, MC minus NB. First step is coming right. Next step. Minus G dash of x. What is going to be? LC minus AN. LC minus AN. Check the next step also over here. G dash of x, LC minus AN. Second step is also right with the sign also. Minus G dash of x. Plus last one. H dash of x. Bacha, have a look. Okay. LB minus AM or MA. LB minus AM or MA. Okay. What I'm getting? This only. It means I have proved that whether you use, I have proved this condition now, whether you use the first determinant and solve for solve for the differentiation. First use determinant and solve for differentiation. You're going to get y dash from here, and this is same as if you just solve the determinant of given the same condition. So using this condition, first one if condition, I proved that second one is valid. Check na. Use the first determinant, the first matrix to find y dash. Same thing is coming from the second matrix also. Y dash is same. Okay, means proved, sir. Proved, bacha. Okay, great. Have a look once again. Now moving to the last problem of the day, sir. The last question of the day. I hope you had fun. I know the session was a little longer. What can I do? I know I took charge that I wanted to solve all the important questions of NCERT. That's why I had to make the session longer. Please not forget to get your class notes. Very important session. Very, very important session. NCERT is the first, right, tool for your examination. So get the class notes. How are you going to get it? Join the WhatsApp channel. Get the class notes, solve all these 27 questions. Very, very, very important questions. I know by now you have already felt that. Okay, so please download the class notes and solve all the questions again, at least 2 to 3 times. Please solve it. This will complete your basic concepts from from the NCERT, and you'll have no trouble solving other difficult type of questions. Okay, chali. So last but not the least, again a question from miscellaneous category. I've taken 3 questions, right? 3-4 questions I've taken on miscellaneous category. Y equals to e power a cos inverse of x. X is between -1 to 1. Show that this is true. Okay. करते हैं. कुछ तो करेंगे sir. Something will do sir. Right ना sir? Right ना sir? Take y equals to e power a cos inverse of x. Differentiate बच्चा. Only one time. Okay. So first differentiation I write as y1, okay, not a problem. Please write. Exponential function will remain as it is, so e power a cos inverse of x. Is it over? Have to use the chain rule. Use it. For this, what I'll have? I'll have a constant a as it is. For cos inverse of x, I'll have what, sir? I'll have -1 upon minus root of 1 minus x square. Okay. Great. Please check. I'm getting what? I'm getting y1 equals to e power, okay, a times of e power minus a times of e power a cos inverse of x upon 1 minus x square. Okay, do one thing, bring this on this side. 1 minus of x square times of y1, okay, equals to minus a, what is this bacha? Tell me here. E power a cos inverse of x. Same thing is this, no? Right here. Minus ay. See. I've taken this cross multiplication. Root of 1 minus x square has taken on this side. Has been taken on this side. So y1 is as it is. Minus a. E power a cos inverse of x is y. So like that. Now do what? SBS. Such a difficult step, sir. Squaring both sides. Kar lenge na turant. Right? Of course, sir. Square it. Root will be cancelled. So 1 minus x square will be the result for this. Y1 square will be this. And I'll have what? A square, because negative will be positive after squaring it up. And y square, sir. Why this, sir? Can you see this here? For that reason. Differentiate again now, bacha. You have to differentiate. Oh yeah, this is very simple. You have to use what here? Product rule again. Let's use it. I have enough space, right? I can use it over here. 1 minus x square times of what? y1 square, right? Please check. Yeah. Equals to a square y square, right? Have a look. Same thing I've written on that side. Because I want to use the product rule, I want to have the enough space. So use this for this part. Keep y1 square as it is. I'll have 1 as 0. This as 2x. Correct? Plus sign will come. Now I'll keep 1 minus x square as it is. Please have a look. And y1 square will be what? 2y1. Please check. 2y1 and derivative of y1. Derivative of, sir, y1 na? Hai na? Derivative of y1, right? 2y1 is which form? Polynomial form. Then I have to differentiate what? y1 also. Chain rule. Equals to a square is a constant. What is this going to be? This is going to be 2y for y square. Derivative of y. How much is that? y1, sir. Understand, the derivative of y is y1. Derivative of y1 is what? y2. Right. What is this going to be? So minus 2x y1 square plus right? Yeah, okay. Plus, how much is that, bacha? Check here. 1 minus x square as it is was there, and 2y1 y2 was there, right? What I get here equals to 2a square y1. Something getting cancelled, sir. I can take 2 common, bacha. So take 2 common. I can take y1 also common. y1 common. Check here. Minus xy1 minus xy1 plus 1 minus x square y2, right? I'm taking 2y1 common, right? So 2y1 common means xy1 is left. This is the end of the left hand side, right hand side. 2y1 is common means what is left here, bacha? A square y is left. Cancel, sir. Cancel, sir. Simple enough. Now do one thing. Bring everything on one side. Write this term first. How come this term first, sir? They have the second square derivative written first here for that reason. So write here 1 minus x square first. y2 is what? Let's write y2 now. Okay. Minus xy1. Bring it over here. Minus a square y equals to 0. I'll write y2 y1 in terms of derivative again. 1 minus x square. Second derivative, right? So d square y upon dx square minus x times of dy upon dx minus a square y equals to 0. Hannah, fun question, sir. Please check. 1 minus x square d square y upon dx square minus x dy by dx minus a square y equals to 0. Same thing is here. Hannah, have a look from here. Please have a look from the very beginning. What did I do? The function was given as y, differentiated first to get the y1 value. From there, took this thing on the other side by product cross multiplication and got this whole square, okay, as this, right. Then I did the product rule of the differentiation on this side, and this was as it is. Please be careful with the steps. Do not make any mistake while writing y1, y2, okay. The final answer is coming as 1 minus x square d square y dx square minus x dy by dx minus a square y, which was the requisite we had to prove. So that, okay, this is it. Visible? Okay. Now, before I end the session, I wanted to tell you important topics that you cannot miss out on. Okay, you have to understand definition of continuity and differentiability. Non-negotiable, bacha, because if they ask you question on prove it to be continuous or discontinuous, what is the definition? The definition was what? Remember, for continuity, sir, LHL and RHL should be equal to the function value at that point. For the differentiability, sir, RHD and LHD, the left hand derivative and the right hand derivative has to be equal to each other. Differentiation rules. How can we prove that the differentiability? Using the differentiation or the first order derivative by putting it as x plus h and x minus h. Okay. Differentiation rules. You cannot forget the formulas, right? Of course. 17th mark is the weightage of the chapter. You cannot forget the formulas. That is not, allowed at all. So you have to know all the formulas. I've given the list of here. Something if I missed, please refer your textbook and get all the formulas. I've not tried to miss anything, but if I missed anything, please refer your textbook and write all the formulas. Maintain a formula sheet. Parametric form. One of the questions which is very highlighted. People ask this question very most often. Question is asked a lot of times. Please remember and solve questions on parametric form. Last but not the least, all the advanced level questions, whether in your PU or in your KSAT, can be used from the which level? Second order derivative. And what happens now, actually, they combine these last three, parametric, differentiation and second order derivative, to make a very difficult question. They don't do it that much for boards. We'll see that in PYQ section, in the next session of continuity and differentiability. But for now, just remember these topics. Definition of continuity and differentiability, differentiation rules, parametric form and second order derivative. I hope this was helpful. I hope you enjoyed the session. I know you enjoyed the session because you only asked for it, right? So if it is lengthier, it's not my problem. You asked for it, you got it delivered. So you know that in our channel, whatever the students request, if the master is saying yes, we want it, sir, we try our best to deliver that, right? So with this note, I would like to end the session. Please keep working hard, keep smiling, okay? Keep positivity around you, bacha. The challenging time is coming. So try to be positive whenever you can. Any queries you have, let us know, okay? talk to your parents, talk to your friends, okay? And if you're having any trouble in your life or your studies, talk to your parents, talk to your teachers, you know. If you can talk to me, please mention me in the comment section. I'll try to answer your queries, okay? With this, I'll see you in the next session. I'm ending the session right now. Please take care and bye-bye.